Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That is one way you can help me promote my channel to keep me going, inspired and refreshed. So this second YouTube channel that I have is intended to present solutions to problems in civil engineering course, or for those who are wishing to become future engineers, not only civil engineering, but that's my ultimate intention, to help the civil engineering community. But allied engineering courses can also benefit from this channel. And I hope that this will help students in engineering to be uh, good in their chosen engineering courses, respective courses. So this is about force resolution, and I present the solution in multiple ways so that for those who are first timers can have ideas on how to resolve a force into its components. And it only requires mathematics, especially trigonometry here. Resolve each of the forces shown below into x and y components by multiple methods. The magnitude of the forces are F1 260 newtons, F2 127.8 newtons, F3 89.25 kilonewtons, F sub 4 136.4 kilonewtons, and F5 360 newtons. So here is the given figure. So force F1 lies on the first quadrant, therefore it is directed up to the right, therefore its components are expected to be positive x and positive y components. And it's just a matter of solving a right triangle. So the slope 5 horizontal, 12 vertical, so the hypotenuse or the distance is 13. Square root of 5 square plus 12 square. So this should be 13. This one. So F1x, as shown in the figure, can be solved by similar triangles or ratio and proportion. F1x as to 5 equals 260, which is this hypotenuse, as to 13. The other way is F1x is equal to the hypotenuse times x component of distance, which is 5, divided by distance, which is 13. So this is F1y, which is also expected to be positive. So again, F1x is magnitude of the force times x component of distance, which is 5, divided by distance, which is 13. Then this is positive because the force F1 lies in the first quadrant. The x component is directed towards the positive x direction as shown. The y component is also directed in the positive direction, upward direction as shown. So F1x is equal to 100.0 newtons. Then, by the way, reported, I always report the answer to 4 significant figures, just like as shown in this problem. F1y is magnitude of the force 260 times y component of distance divided by distance. So 260 times 12 over 13, and that is also positive. So 260 times 12 over 13, and that is equal to 240.0 newtons. That's the first way. Now, in terms of the angle, remember from trigonometry, angle is measured positively in counterclockwise direction from the positive x-axis. This is the terminal side of the angle or the force. Therefore, this angle here in counterclockwise direction is inverse tangent of 12 over 5. So inverse tangent of 12 over 5 is 67.38 degrees, and that's positive because from the positive x-axis to the terminal side of the angle or to the force, direction of the force, it's counterclockwise. So therefore, the x component, F1x, is magnitude of the force cosine of that angle. So F1x is 260 cosine of 67.38 degrees. So F1x is 100.0 newtons. F1y is 260 sine of 67.38. So that's the advantage because we don't need to think of the sign of the component or components. So it is also equal to 240.0 newtons. Now, if you express the solution into a negative angle or clockwise angle, then it is negative of quantity 360 minus 67.38, and that's negative 292.62 degrees. So F1x is 260 cosine of negative 292.62 degrees. It will give us the same answer. F1y is 260 sine of quantity negative 292 rather 0.62 degrees. It will give us the same answer. So I'll just present this. You verify using the negative angle 260 cosine of negative 292.62 degrees. It will give us this result. F1y 260 sine of negative 292.62. It will give us that result. And let's proceed to F2. So the component F2 is directed up to the left, so the x component is expected negative as shown, and the y component, because it is upward, is positive. So the x component is adjacent to this 28-degree angle. Therefore, F2x, and it is expected negative, magnitude negative 127.8. It is adjacent, so cosine of 28. So it is negative. The negative sign is anticipated because F2x is in the negative direction. So negative 127.8 cosine of 28. Negative 127.8 cosine of 28. So F2x is negative 112.8 newtons. F2y is expected positive. It is opposite to 28. So it is hypotenuse 127.8 sine of 28. And it is anticipated to be positive. So that's the first solution. So 60.00 newtons. For the second solution, the angle that this force makes with the positive x-axis in counterclockwise direction is 180 minus 28, and that is 152 degrees. Therefore, without thinking, F2x is magnitude of the force 127.8 cosine of 152. So it will give us negative 112.8 newtons. Then F2y is 127.8 sine of 152. So F2y is equal to 60.00 newtons. Then if you express it in terms of a negative angle in clockwise direction, it is from the positive x-axis clockwise, that's 180, negative 180, then negative 28, negative 208 degrees. So F2x is 127.8 cosine of negative 208 degrees. So it will give us the same result of negative 112.8 newtons. Again, negative 208 is negative 180 and another negative 28. The angle is negative in clockwise direction from the positive x-axis. So that's negative 180, straight line angle, negative 28, so negative 208 degrees. F2y is 127.8 sine of negative 208. So F2y is 60.00 newtons. So for the next force, let's have it on the next slide. So for F3, the magnitude is 89.25 kilonewtons. F3x, because the x component is directed towards the negative x-axis, it is expected negative, and F3y is going down, so it is also negative. Now, in terms of the angle that the force makes with the x-axis, because this is 57.4, the measure of this angle is 90 minus 57.4, and that is 32.6 degrees. So F3x is adjacent to this angle, so it is expected negative also. So it is negative 89.25 cosine of 32.6. That's F3x. And that's the first way. So negative 89.25 cosine of 32.6 degrees. So F3x is negative siya kay ang direction of the component is towards the negative direction. So negative 75.19 kilonewtons. F3y on the other hand is opposite of 32.6, and F3y is expected negative, so it is hypotenuse sine of 32.6, but a negative sign is preceded to this magnitude. So F3y is negative 89.25 sine of 32.6 degrees. So F3y is negative 48.09 kilonewtons. Now, in terms of this 57.4 degrees, this is F3x negative because it is expected negative. The x component is directed towards the negative x direction. And this time, it is opposite of 57.4. So it is negative 89.25 sine of 57.4. So F3x is negative 89.25 sine of 57.4 degrees. So F3x is negative 75.19 kilonewtons. F3y, it is adjacent, but it is expected negative. This one is equal to this. So adjacent to 57.4. So it is also expected negative. So it is negative 89.25 cosine of 57.4. So F3y is negative 48.09 kilonewtons. Now, in terms of the positive angle, which is 180 plus 32.6, that's 212.6. So F3x is 89.25 cosine of 212.6 degrees. So it is equal to negative 75.19 kilonewtons. F3y is 89.25 sine of 212.6 degrees. So it is equal to negative 48.09 kilonewtons. In terms of the negative angle, negative 90 and negative 57.4, that's negative 147.4. I will leave that to you to show that these are really the components. So the angle, if it is expressed in terms of negative angle, it is negative 147.4. Then for F4x, since F4 is directed downward, there's no movement horizontally. F4x is 0. The magnitude is 136.4. So F4x is 0. By just looking at the figure, there's no movement horizontally. F4, because it is downward, purely downward, then it is negative 136.4 F4y. Now, in terms of the angle, from the positive x-axis to this direction, that's 270 degrees. So therefore, f4x is 136.4 cosine of 270 degrees. So it is 0. Then f4y is 136.4 sine of 270 degrees. And therefore, it is negative 136.4 kilonewtons. In terms of negative angle from the positive x-axis in clockwise direction, it is negative 90. So f4x is 136.4 cosine of negative 90, and that should also be 0. And f4y is 136.4 cosine of negative 90, and it is equal to negative 136.4. So finally, for this f5 here, the x component is rightward, so positive. The y component is downward, so negative. So we have 3, 4, so the hypotenuse is 5. Square root of 4 square plus 3 square is 5. So the magnitude of f5 is 360 newtons. f5x is positive because it is directed towards the positive x direction. f5y is going down, so it is expected negative. Now, in terms of these components of distance, f5x is magnitude of the force 360 times x component of distance, which is 4, divided by distance, which is 5. So f5x is 360 times 4 over 5, and it is equal to 288.0 newtons. f5y is negative, so it is negative 360 times 3 over 5. So f5y is equal to negative 216.0 newtons. Then in terms of this angle here, arctan of 3 over 4 is 36.87. f5x is expected positive, so f5x is 360 cosine of 36.87. So it is 288.0 newtons. While f5y, because it is expected negative, it is negative 360 sine of 36.87. So it is negative 216.0 newtons. Because from the positive x-axis, the direction of this angle is clockwise, so 36.87 is negative 36.87. So f5x is 360 cosine of negative 36.87, and it is equal to 288.0 newtons. f5y is 360 sine of negative 36.87, and it is equal to negative 216 newtons. In terms of positive angle in counterclockwise direction, 360 minus 36.87 is 323.13. So f5x is 360 cosine of 323.13 degrees, and it will give us the same value of 288.0. And f5y is 360 sine of 323.13 degrees, and therefore it is equal to negative 216.0 newtons. So that's it. I hope you were able to follow the solution, and I presented so many ways so that you will have an idea how to resolve a force into its components, not just by all the four, but I want you to have the force resolution by anticipating the sign and using the angles or dimensions in the figure. So I also give you an exercise. Do this, and I want you to present at least 4 methods and verify that the answers are the ones that are displayed in this video. So we have this force with F6 with magnitude 625 newtons, and these are the informations. And we have F7 136.6 kilonewtons, and this angle is 118.2. So show that F6x is equal to negative 175.0 newtons. F6y is equal to positive 600.0 newtons. F7x is negative 65.5 kilonewtons, and F7y is equal to negative 122.1 kilonewtons. So if you can present this into at least 4 methods, that means you already know how to resolve a force into its components, and you are ready to solve problems on systems of forces in the future.